I have already done, that is scattering of light, but we'll try to understand in more details about the scattering of light and what is the word intensity and on what does it depend. When the sunlight enters the atmosphere of the earth, the atoms and molecules of different gases present in the atmosphere absorbs the light. There is always absorption of light as it passes through different layers, and as the different layers are made of different gases, they also absorb the light. Now, then these atoms and molecules of gases re-emit the light. They absorb and they re-emit the light in all directions. This process is known as scattering of light. We have done something which is called spectrum, that is formation of light entering white light, and bending, that we call dispersion. Here the concept is scattering of light. As the light enters from the sun to the different layers of atmosphere, and different layers of atmosphere consist of different atoms and molecules, they absorb the light. First they absorb the light and then they re-emit the light in all directions. This all directional emission of light is called scattering of light. The atoms or the particles scatter the light, and this is known, the atoms and particles or the molecules which scatter the light are known as scatterers. The atoms or the particles which are responsible for scattering of light is known as scatterer. The intensity of scattering of light is inversely proportional to the fourth power of the wavelength of the incident ray. This intensity of the scattering of the light is inversely proportional to the fourth power of the wavelength of the intensity of the light. If the size of the particles, say that the atoms or molecules, scattering size of the particles, that is atoms and molecules, are small in size as compared to the wavelength, then the scattering of light is less. Scattering of light is less than the wavelength. Now the intensity of scattering of light, I, is proportional to 1 by 4th power of wavelength. We know that wavelength of the red light is greater and the violet is the least. And violet is the least. Blue or violet is less, but violet is the least. Now, the intensity of scattering of red light is less than the intensity of scattering of blue or red. The absorbing capacity of light, sunlight, by a red light is more, but re-emission is less because of the wavelength factor. Blue light absorbs and emits maximum. So a red light remains red. Therefore, the red light is always used as a signal for danger. For traffic stop, for the tall buildings, for towers, microwave towers, we call this mobile phone towers, multi-story buildings, skyscrapers, or places of importance or high, where there wouldn't be any accident, or for easy for identification of flight, or easy of identification while traveling, so that you can see the red light. Even if you see ambulance is written in red light, red color, even the plus sign of the ambulance, which is of the doctors, is given in red. So red absorbs the light, emits less, so it is very, very visible. This is because of the intensity. Now the blue color of sky, the greenish color of the greenish blue color of the sea, red color of the sunrise and the sunset, and the white color of the clouds, and when you say, these are also due to scattering of light. We'll discuss one by one all this, and we'll try